In this problem, we're given a filter network. We're asked to sketch the magnitude characteristic of the voltage plot for GV of j omega. So, GV of j omega is going to be V0 of j omega over Vs of j omega. So let's convert the circuit to the frequency domain and derive that transfer function. So here's our circuit in the frequency domain. And we can do this by voltage division. So V0 of j omega is 50,000 over j omega divided by 50,000 over j omega plus 10,000. Now if we multiply numerator and denominator by j omega, we have 50,000 divided by 50,000 plus j omega 10,000. And now let's convert it to standard form, and when we do that, let's divide the factor out of 50,000 out of the numerator and denominator. Then we're going to get 1 over 1 plus j omega over 5 times Vs of j omega. So then GV of j omega, which is this ratio, then just turns out to be 1 over 1 plus j omega over 5. So now if we look at that characteristic, we basically have a simple pole, okay, at omega equal 5. So then our characteristic, really what we have here is a low-pass filter. Okay, so let's do the plot. And here's a magnitude of GV in dB. So this plot has a gain of 0 dB, and then at 5 radians per second it breaks down at 20 dB per decade.